Math Blast 31, Tuesday. Commutative property. 4 times 8 equals 32. So 8 times 4 equals 32. The commutative property of multiplication states that two numbers can be multiplied in either order, and I'm still going to get the same product. Division as unknown factor. Determine which number correctly answers both equations. 36 divided by 6 equals blank, or blank times 6 equals 36. We can think of division as an unknown factor problem. 36 is my total, and I need to divide or equally share that into groups of 6, or into 6 groups. In this case, I'm going to share that into groups of 6. So I'm going to skip count by 6. 6, 12, 18, 24, 30, 36. Notice I have 6 groups of 6 there. So 6 times 6 is 36. Therefore, 36 divided by 6 must be 6. Two-step word problems. Sam had 12 candy bars. He went to the store and bought 4 more. His sister asked for half. How many candy bars did each of them get? If Sam had 12 candy bars, I'm going to note that in a tape diagram. He went to the store and bought 4 more. So we're going to add 4 more bars here. And 12 plus 4 would give me the total, 16 candy bars. Now, if his sister asked for half, we're going to take the 16, the total here, and we're going to break that into 2 parts. How much does each person get? So one group of that would be taking my 16, and I want to equally share that into 2 groups, 8 and 8. So I'm going to state each gets 8 bars. Whole numbers as fractions. Use the model to write a fraction for one whole. So I notice there are 4 equal parts in the whole rectangle there. And all 4 parts are shaded. So we're dealing with fourths, and 4 fourths would equal 1 whole. Write a fraction equivalent to 2. Well, if 4 fourths is 1 whole, then 4 fourths and another 4 fourths would be 2 wholes. That would be 8 fourths. Elapsed time. Write the time shown on each clock. So here, again, when we're talking about time, time is told with hours and minutes. I look at the shorthand to determine the hour and the longhand to determine the minutes. So as for the start time, let's look at the shorthand, and I notice that it is past the 10, but not quite to the 11. So we're still in the 10 o'clock hour. And then I look at the longhand, and I notice it's at the bottom of the clock. Now the top of the clock at the 12 would be 0 minutes, o'clock. And every time we move to a new number on the clock, we've passed 5 minutes. So we go from o'clock to 5, 10, 15, 20, 25, 30. It is 10:30 p.m. For the end time, I take a look at the hour hand, and it is at the 11 o'clock hour. We're in the 11 o'clock hour, and when I look at the longhand, I can determine the minutes. Again, start at the top of the clock at o'clock and count by 5s. 5, 10, 15, 20. It is 11:20 p.m. How much time has passed from start to end? So going from 10:30, if I want to go to the next hour, that would be 30 minutes, and that would get us to 11 o'clock. And then I want to go to 11:20. So 20 more minutes is what it took to get to that 11:20. So now I add the 2 parts here. 30 minutes and 20 minutes would be 50 minutes. 50 minutes has passed. That's the elapsed time. On the back side, measuring capacity and mass. If a student fills the beaker to the arrow, how much water will be in the beaker? So taking a look at the beaker, the first tick mark is represented with 100 milliliters. And then the third tick mark is represented with 300 milliliters. So just like yesterday, we have this one right in the middle of our 100 and 300 milliliters. We know that should be 200 milliliters. So each tick mark, as we move up each tick mark, we're counting by 100 milliliters. So let's start here. We have 100, 200, 300, 400, 500, 600, 700, 800, 900 milliliters is where the arrow is. The scale shows the weight of the ball. How much does the ball weigh? Looking at the scale, I see that the measurements are in kilograms. The start is at 0, and it's counting by 1 kilogram here. And at the bottom of the scale, it's right between the 4 and the 6, so that ball would weigh 5 kilograms. Bar graphs, birthday of students by month. On the vertical axis, I have the number of students, and I notice the scale, we're counting by 2s. And on the horizontal axis, we have the months from January through December. How many fewer students have birthdays in April than February and March? So let's look at April. The bar for April goes between the 2 and 4 marks, so 3 students had April birthdays. For February, the bar goes up to the 4, so we have 4 students who have February birthdays. And for March, our bar goes to the 2 March birthdays. So now let's answer that question. How many fewer students had birthdays in April than February and March? So for February and March, we want to add those numbers. 4 plus 2 is 6 students had February and March birthdays. If 3 students had April birthdays, we now want to subtract our 6 minus 3. And so 3 students, there would be 3 fewer students